Good afternoon, everyone, and welcome to this info session on how to kickstart a career in artificial intelligence and machine learning. I am Professor Brinda Sampath, and along with me today, I have Dr. Sridhar Pappu, and we're going to walk you through the importance of artificial intelligence and machine learning. And we're also going to talk about the program that we're jointly offering at NMIMS along with our knowledge partners in Survey. So before I start talking and getting into this entire space, let me quickly tell you a little bit about Dr. Sridhar Pappu, right? And the kind of experience that he carries that will basically help us know a lot more about this field, right? Dr. Sridhar has basically donned various roles, okay, right from an engineer in Silicon Valley to a scientist in the Indian Defense Establishment building. He carries over 17 years of industrial experience, where he's worked on multi-million-dollar semiconductor fab automation projects for customers in the US, Europe, Asia, okay, and basically worked with IBM, Seagate, the TDK Group, LSI Logic, and the National Semiconductor. Prior to InSurvey, he basically managed many large data analytics, Web 2.0, and internet projects while working with companies like Prithvi Information Solutions. Okay, he's worked for Axaya, Cybertech, and the KLA 10 Core Corporation. Dr. Sridhar Pappu is responsible for the academic administration of the institute and for ensuring the highest standards in learning at InSurvey. He's basically been named as the Lifetime Achiever by Marcus, Who's Who in the World 2017, and a member of the Editorial Advisory Board Handbook of Materials Structures, Properties, Processing, and Performance by Dr. Lawrence E. Moore. He carries an MS and a PhD in material science and engineering from the University of Texas at El Paso, USA. And he also carries a degree in BE in metallurgical engineering from NIT Trichy, right? So here we've got Sir, who's going to brief us about what it takes to basically build a career in AI. All right. And before we get into this entire discussion with Sir, and before I hand over, the rights to him to basically walk us through this, let me just introduce to you the two institutes that have come together to offer this program, MSc in AI and Machine Learning Ops. Okay, and what is the program that we're really doing? So the two institutes, speaking of NMIMS, okay, we basically NGASCE, that is NMIMS Global Access School for Continuing Education. We're one of India's top EdTech universities, and we're the distance learning arm of NMIMS. We have over 70,000 students enrolled across various programs that we offer all across the country, right? NMIMS has a legacy in technology. We've got two schools, basically, the Center of Excellence in Analytics and Data Science, and we've also got Mukesh Patel School of Technology Management and Engineering, right? And speaking of our knowledge partners, InSurvey, which is the International School of Engineering, is one of Asia's largest data science schools, okay? And they are our knowledge partners who are going to help us provide deep technical training in the field of AI, data science, and machine learning. InSurvey is the world's leading research-driven educational institutions when it comes to applied engineering, and they've got renowned faculty members that hold PhD degrees from various reputed international universities. All right, so speaking of our program today, let me now hand over to Dr. Sridhar, who will walk us and let us know more about how do we go about building a career in AI and ML. Right? So over to you, sir.
Thank you, Dr. Brinda, and thanks for that nice introduction. Well, I don't Actually, I have put up some important points in there, but that was not the important. I think the important point that you really caught was that my degrees are in metallurgical engineering, material science, and engineering, and maybe many of our participants might relate to some of these things. And today I'm doing data science, AI, ML, and that should give us a grip of understanding how this field is evolving and who are the types of people who are actually leading that. And so about 25 years experience, but primarily when I was working on in KLA Tencor in the Silicon Valley after my PhD, that is where some of the data science related thing came into being. Statistical analysis started coming in, and the IBMs and all those other things that Professor Brinda mentioned. As KLA Tencor, I was helping them build these latest technologies. The Intels of the world were using our equipment, and some of the statistical analysis needed to go in there. So a metallurgical engineering, a material science PhD, of course doing material science part of it, but analyzing data where statistics was important. And now a lot more evolution has happened over the past 20 years since I finished my PhD, and a lot more things are being done. And that's key to today's webinar on how do you want to kickstart your career in AI and machine learning ops, dealing with AI and machine learning. What can you do? What should you be able to do? And that is something that I want to emphasize in today's talk. And um, there's a hand that has been raised. I believe questions can be posted on the chat window, etc. And I'll keep a watch on them. But primarily, because there's a very short session, some of these questions, if they are not immediately pertinent to what I'm talking about, we can address them afterwards. So I'll talk about for about 30 to 35 minutes. I hope everyone is able to listen to me or hear me well. If that is not the case, let me know. But other than that, I'll spend about 30, 35, 40 minutes on this, and then we will talk about the program, and then we can have a lot of questions as long as you want. But briefly, the agenda, I'll talk about AI and ML, briefly about data science. So a lot of terminologies that are coming in: artificial intelligence, machine learning, data science. What is all this crazy stuff going on? So I'll talk about that. But along with that, where is this field heading to? I mean, what are we expecting out of this? Whether you want to call it AI, ML, data science, I'll define them. But where is this field heading, and which industries are looking for it? Because that's something that will be of interest to everyone. Is it for me? Is it not for me? So who is looking for it and are unable to find the talent that is needed for that? Then, is my background really suited? I already mentioned that I have a material science background, but I am doing this day in and day out. How are these things related? Where do these things come in, and is it really for me or not? Can I build a career in this thing or not if my background is something else? And then, what kinds of roles should I be able to expect if I get into this field? Where is the career headed? And then, obviously, uh, after understanding what data science, AI, ML is, how do I really kickstart? Where do I get started? Because there is so much talk about it, so much hype around it, so much of newspaper articles with all these fancy things happening. Can I do it or not? Or if I want to do it, how can I do that? How do I kickstart? And obviously, getting a formal education, a degree, etc. And that helps. And that's where about the program specifically, we will talk about. Dr. Brinda will actually spend some time, and we can all address any questions you may have around any of these topics. So that's primarily the agenda for today. Okay, so AI, ML. AI stands for artificial intelligence, ML for machine learning. And what are these? Because everyone tends to use these interchangeably in different ways. And to some extent, I think everyone is right. And if you look at these diagrams here, two different diagrams, one thing seems to be suggesting that artificial intelligence is that big bucket where machine learning is part of it, and then deep learning is even deeper part of machine learning. Whereas the other one suggests that, well, whereas deep learning is the combination of AI and ML, AI and ML have some overlap but some differences also. So let's try to understand and define them. And I'll use pretty much some of the definitions from the experts and from the School of Computer Science in Carnegie Mellon University, which is practically most of the time rated number one university for computer science in the world. And we have had quite a bit of experience interacting with them and while building in Sophie. But the university professor Tom Mitchell, he also has a book on machine learning, which is considered a great book, which is a wonderful book. And he has defined machine learning in a nice way. And let me first read it out. Machine learning is the study of computer algorithms that allow computer programs to automatically improve through experience. Okay, let's reflect on that thing. A lot of computer stuff. So is it only for computer scientists? Like I said, no, not really. But what is that? And Professor Mitchell actually gives a small example. Ideally, the idea from the 1950s, when Alan Turing said that we want to build machines that should be able to learn as humans learn. So that's machine learning. Machines are learning. But Tom Mitchell's definition, really, how do machines improve with experience? And example he gave was, for example, the experience the machine has is a playing a checkers game or a chess game multiple times. That is the experience. The task is that it is playing the game, and the performance metric that it's checking all the time is whether it's winning or not. If it is winning, it's doing a good job. If it is losing, how can it improve based on the past experience, past data, to actually now improve and actually do better in future? So machine should be learning by itself. That's what is machine learning essentially. So you have a lot of data, past experience. You actually now uh, train and play that game or do whatever, build a model, and then you try to predict something. And if your predictions are good, then you are doing well. If they are not, how can you learn and improve yourself? So that's what a machine should be doing. So what is artificial intelligence then? Well, another dean of the same School of Computer Science, Carnegie Mellon, said that artificial intelligence is the science and engineering of making computers behave in ways that until recently we thought only humans could do, require human intelligence, artificial intelligence as opposed to human intelligence. And so this seems like a very broad one. And in that sense, this diagram that says artificial intelligence is a very broad category within which machine learning can be there. So that's what we are trying to really achieve. Try to be able to behave like humans. Machines are being trained, or they have to train themselves in behaving like human beings. One more definition, just to show you how sometimes it's ambiguous, sometimes it's very generic, not very specific. And so why should, and that's why we should not even bother too much about trying to see the distinction, whereas some distinction can be made. AI is aspirational, a moving target based on those capabilities that humans possess, but which machines do not. Now, and it's a moving target. And that's a pretty good understanding if I combine both Professor Moore's and Professor Lipton's definitions in this artificial intelligence context. Let's go back and take the example of the chess playing computer. Years back, that was artificial intelligence. It was trying to understand how humans are playing and trying to do that thing. But now, every computer, every system has chess games built in. It's pretty common. It's nothing aspirational anymore, and it has now become machine learning. And machine has learned how to play it. So now the artificial intelligence probably is all these self-driving cars. Okay, so that's where we are looking at, and what are those algorithms that are able to think like humans and be done with that. But then again, it's a moving target. Years down the line, that becomes machine learning something else. So to rather than really get hung up on the definitions, we can think of these as computer algorithms that are trying to help us understand humans, transactions, machines, all nature, all kinds of things through data, and then try to mimic that, help us understand that, to be able to do better predictions, take better decisions using that knowledge that we have gained through data. So essentially, it all boils down to that, and something fancier that is still evolving, we may call artificial intelligence or otherwise machine learning, but both are very important aspects. Another way to look at that with simple example is machine learning could be defined as those that humans find difficult but machines find easy, whereas artificial intelligence is something humans find very easy, machines find it hard. For example, I have to predict um, uh, let's say simple, the price of a house, and there are many variables. There is age of the house, the size of the house, the number of bedrooms, number of bathrooms, locality, the school district, variety of factors that are there. Now, as a human being, if all that data is given to me to process equations in my mind, that's become very difficult. But if I have past data and I can actually create an equation based on past data, now the machine can process all these things very nicely and do it very quickly. That probably is machine learning, and it can evolve as new data comes in. It learns from experience. Artificial intelligence, a common example is given that humans can identify objects very easily. Nowadays, of course, machines have also become equally good. But when even a baby sees a cat or a dog, initially the baby doesn't have a clue what is that, but you have to tell the baby that it is a dog, or in baby's language it's a bow bow, and meow meow, you have to just mention that. And after seeing quite a few meow meows and bow bows, the baby is able to figure out. But if I have to teach the machine to be able to identify, how do I do that? If I say it has four legs, well, both of them, two ears, two eyes, how do I am, as a human being, I can immediately process and tell what is cat, what is dog, but I cannot teach a machine because I myself don't know how to really define a cat or a dog. And so I cannot teach. But now, if I give enough things, can the machine think like human beings? And after seeing enough pictures, can it figure out? And that's where machines have actually a difficult job. Now they are getting good at it, but humans find it very easy. So artificial intelligence kind of things, as Professor Lipton says in the bottom, is aspirational, where humans possess those capabilities but machines do not. And so how can machines be trained to do that? That's where this whole field of AI and machine learning is. But practically speaking, we look at a variety of different types of algorithms, models, techniques that can solve variety of different problems. I'll give you a sampling of that in the next few minutes. But before we get there, what is data science? Haha, another buzzword these days that we are talking about. And I'll show a couple of definitions from Wikipedia. One was there in the past, long past. One is there currently. Both are good definitions. The whole idea of AI ML data science is that you have a lot of data from anything, okay, and you are trying to extract some insights, some patterns from that data, and use not all available data, but a lot of that data is junk. Identify using these techniques, statistics, other kinds of techniques, what data is useful, what is junk. Use only the relevant data, extract meaning from there, and create products, platforms, solutions, etc. Not only that, finally convince the bosses using a story, using nice visualizations, charts, etc. and that can be understood by non-practitioners in a simple way, so that a data science project can be successful. So a variety of aspects to that. I will talk about what skills you need to gain, but and what skills are completely lacking, and where are these specializations, and all of that I will talk about. But that's the whole idea about a data scientist or an AI ML practitioner. I have a lot of data, I use some jugglery, some magic, something, and some mathematics and computer science, etc., to be able to actually build nice models that can do a good prediction, and we can live better. How do I do that? Is by actually using the methods involved in statistics, analyzing data, which uses that, machine learning, which are kind of non-statistical methods, more driven by computer scientists who have developed pattern recognition methods, etc. All of these things to understand the real world phenomena, and it leads to a beautiful discipline, because we will see, as with many examples, that while the underlying techniques are the same, you can solve problems in a retail industry, in a healthcare industry, in a manufacturing industry, in a transportation industry, logistics, anything, government, policy making, using the same knowledge, same techniques that you have learned. And that gives a lot of nice, beautiful, challenging environment for us to keep solving world's problems in variety of different ways. So that's what data science is going to be. Let me show you a few examples of what kinds of things can be solved. This is very, very small thing. We have a very short time here, but some common things that people are doing day in and day out. Pele has a habit of making predictions in before major tournaments. Who is going to win? And some of his predictions, I'll just show a few of them. Colombia will win 1994 World Cup in USA. Spain favorites for 98 World Cup in France. China qualifies to the final playoffs for the second 2002 World Cup championship. Argentina and France will both reach the final in the second 2002 World Cup. In all of these cases, all these countries lost in the first round. Pele also said Brazil won't get past the initial stage in World Cup 2002, and Brazil went on to win 2002 World Cup. Now, you cannot say Pele doesn't understand football. Pele is the greatest footballer of all time, arguably. And Pele is not making random statements. He is analyzing people, their teams, their performances, and he is making predictions. But this is where the definition of machine learning comes in. Human beings find tough. I may have good understanding of how the game is played and how each person is doing, but the moment I have to take in a lot of these data and process them in my mind, machines are going to be able to do a much better job than we do. And let's see what some of these machines did in 2004 World Cup. Google's Cloud, Baidu's Trends, Microsoft Cortana, all of these made 14 to 15 out of the 16 games that were played. They predicted correctly what will happen. Now that's machine learning, what is being done. And if you are dealing with Alexa, Google Home, Siri, Cortana, whatever, you are dealing with AI and ML on a daily basis. Your life is surrounded by that. You go to websites, you see some ads getting popped up, and you wonder, I just saw something in some shopping website, something, and suddenly everywhere else that's popping up. Well, data is the king. Data is the latest oil, whatever you might want to call it. These AI ML algorithms are running, and we all have the ability to do that. We don't have to be computer scientists only to be able to do that. They have certain benefits in certain types of jobs, but this can be done because there's a lot of logical thinking involved in all of this. And Germany defeated Argentina. So Cortana said it's too early to say for sure, but I would give Germany the edge. And actually that was true, but all of them were wrong in the third place result. So it's not a foolproof thing. So there is a question. I'm trying to see if I can predict court cases outcomes from a database of cases and the past trend, and then perhaps can identify learnings of judges on certain factors which fundamentally determine the case outcome. What techniques would you recommend? I am a finance and tax professional with some good knowledge of stats and maths, cluster and KNA. Okay. And I understand from my limited study. Okay. Okay, so now this question, we probably have to take it afterwards, because there may be many people who don't know what K nearest neighbors are, and stats, maths, cluster analysis, and all those kinds of things. But see, legal things are, you can predict what may happen If you want to look at similar cases, etc., a lot of text is there, a lot of decision making. What are the kinds of things that judges have considered in the past? But obviously, you would not want to let AI take that judgment and pass that judgment, because that still has to be based on facts as we can analyze. Okay, but a lot of um, uh, getting these documents that are there, being able to read those documents automatically and highlighting the key important things, etc., that is something that text processing related things are summarizing the document, summarizing judgments. You have so many past judgments available, you should be able to do those kinds of things. And then obviously, if you really have to get into the prediction of that judgment itself, you will have to have an analysis of that particular judge's analysis also. Just like the judge Ganadiwala recently has been giving variety of judges judgments, and the rest of the judges don't agree with that thing. So it's a pretty tricky thing in being able to predict. You can make predictions, but the accuracies, I would believe, would be way off. And I don't see how much value that can also generate. But being able to summarize documents and quickly do those things, that's all already being done. AI can read those documents and summarize the key points, find a lot of things there. So that's something that I can say at this point of time with this thing, not getting into what techniques and other things. That's really not something I can answer also at this point without being able to see all the data. And a key, whoever asked the question brought a very good point. The key important thing is also to be able to understand that domain. I have to understand something about law. I need not get degrees in law, but how are judgments made by people? What goes in some analysis of that data? And that is something that I will talk about, and how this program, the MSc program jointly being done by NMIMS and in Sophie, is bringing those components by bringing in the strengths of the two organizations. So at this point, I think I'll stop with that on that particular question. The person who asked the question can pose a follow-up question on that thing, but we can take that offline. Continuing on with the applications of these things, retail analytics, I'll go a bit quicker on this part of it. But Walmart, again, a nice, beautiful example of how. So these are the things that will give you an idea of how to think about AI, ML, data science. And so Walmart in 2004 found that strawberry Pop Tarts, and these are edible things like this, some munching stuff, these sales were shooting up by 7 times over normal shopping days. And that didn't make sense, because if a hurricane is approaching, normally people stock up on essentials, water, milk. These are the kinds of things that people stock up on, warm clothing, whatever. Those are the kinds of things they do. But why strawberry Pop Tarts that kids like most of it? Data science has helped them, and it has helped both Walmart and the consumers. Let's see what it is. They saw with the data that just before hurricanes, these sales were increasing. That was what the data was telling them. That's clearly visible. So they started analyzing why, and they realized that strawberry Pop Tarts have a lot of nutrition. They need not be cooked. At a hurricane time, electricity goes off, power goes off. You don't have to cook. These need not be frozen. Fridge is not needed. Kids like them, adults like them, everyone likes them. And they are just easily available. You can eat anytime, give you a lot of nutrition, tasty food. That's why. And so what's the decision they take? They started storing. Whenever hurricane season is about to come, they stock it up. How does Walmart benefit? They have more sales. How do people benefit? They don't have to run around, because when people are suddenly buying off the shelf, then someone else goes, they don't find it, it's over. Walmart can predict how much people are going to buy, stock it up. Consumers don't have to run around, hurricane is about to hit, and they are able to stock up on all of these things. So that's how data science can help with a variety of things. Like this, many examples are there, something that you must be seeing all the time if you are shopping on Flipkart, Amazon, etc. If you are looking for a treadmill in these pandemic things, yes, that's fine. But data science is telling you something. That people who bought this also bought a stabilizer, probably makes sense, because this runs on electricity. Haha, but they also buy potato chips. You would think that's kind of unhealthy. Okay, so it was treadmill on the one hand, potato chips, but oh, who knows? I like to eat my potato chips. I am burning it off anyway. So while running on the treadmill, I might be eating. But the data shows that they are going together. If the models have been built well, maybe that's a fact. Think about why it is and take a good decision, and maybe have a potato chips rack next to treadmills when they are selling treadmills in a store there. So things like that can be done. All kinds of things, industries needed. Pharmaceutical, that's happening a lot right now. All these clinical trials, even some people who have been given placebo, that it's not real vaccine. Some others, is there a significant difference? What is it doing? All these are numbers and basic statistics that in fact we cover in even in our first module when we start teaching statistics, right from mean, median, mode. People would have forgotten median, mode, etc. But from there you get to do all these kinds of things that you can understand what's going on. Drug development process important to speed up, identify which experiments are going to fail before they fail, and stop those experiments. Variety of these kinds of things, banking, financial sector, and insurance services, all those kinds of things, fraud detection, cross selling, upselling. And like I said, what you do in one thing can be applied in a different thing. Travel and hospitality industry, this Uber's dynamic pricings, aircraft dynamic, airlines dynamic pricing, etc., are all data driven. And all these kinds of techniques that we learn, they can just work and help you do these kinds of things. Healthcare, medicine, we have been seeing that all the time. AI is improving cancer diagnostics. You look at the radiograms or the x-ray things, images, and automatically actually identify what kind of a tumor or cancer it is. It helps even physicians, and it's not going to replace a doctor, but it gives them more time, where this actually has a better accuracy of identifying the right cancers, and then the physician can actually spend time on treating rather than spending time on looking at these things, and these are much faster. So AI, ML, etc. is moving in all these directions. Retail, telecommunications, heavy. Government is policies, policing, and variety of things. These are very difficult. Weather predictions are improving a lot. Calamity predictions are still very difficult because past data is limited. So data science, after all, AI, ML require data, and if you have past data, you can do better. But people are improving all these kinds of things. Politics uses heavily to identify who is going to be voting against you, who is someone who is for your party all the time, they are going to vote. Someone who is against all the time, they are not going to wait. But some people who are voting based on the actual scenarios that they face, the situations, how is the governance being done, and all those things. That's when you have to understand what is it that is impacting those people's emotions, and then you can actually take better decisions. Harvard University is teaching the United States Congress about AI, because if they have to build policies around the AI usage, they have to understand it. So it has become a mainstay for everyone. Your railway tools, you if you are booking train tickets, you would be seeing this. This is an actual screenshot I saved last year before the pandemic, and Kalka Shimla train, etc. Probability of confirmation 62%. It is waitlisted currently, but the probability that it will get confirmed is 62%. Data science. In fact, the same algorithm that will answer this, whether the train ticket is going to get confirmed or not, same thing you can take it to a retail situation, where you can say whether a person is going to buy your product or not. The same in healthcare, whether a person will get a heart attack in the next 10 years or not, based on their BP and these other things. These data will change, but the same algorithm, same knowledge that you have gained, the same math behind that, is going to solve variety of problems across domains. And that's what makes it so exciting to actually deal with these kinds of algorithms. And with smart cities coming up, smart homes, well, how to optimize the use of your utilities. If the demand is increasing in certain areas at certain times of the day, then you might want to supply more power there and not waste it somewhere else, and all those kinds of things, make more money. by giving power cuts can be reduced. All those kinds of things can be managed. A lot of things, smart tools, IoT is there, sensors are everywhere, a lot of data is being collected, and you can do that. Simple example, futuristic kind of an example, could be very useful. Your medical tablets box is there. Senior citizens are at home, and you have the tablets, and the sensor sticker is attached to that. You take one tablet out, it senses it. It may be able to send a message to your Alexa, Echo Dot, or something, and says, well, you have taken the medicine. Or if you forget it, Alexa pops up at 11 o'clock today, you were supposed to take a medicine you did not take. And so it is such a nice, beautiful benefits it can have. Of course, every good thing can have very negative things also. So all of these things are part of that game. So this is a lot. So it's not just about doing autonomous cars, which is a big thing, which is improving a lot, which is also part. The kinds of techniques we run can be uh, uh, extended upon and used in all of these things. So very powerful, but very exciting field to be in. So exciting, why do I say that? What is the future holding for that? That's important for me to understand. To see the future, as I am a data scientist, I look at the back past. And 2015, 40% of the companies said they don't have the right talent. 2018, desperate for data scientists, and that's the email I received. LinkedIn says 151,717 people, 151,000 more jobs in US alone exist than the supply is there. Come 2020, and I'm going to be showing quite a few these screenshots from this study that came out only 3 to 4 months back, World Economic Forum, the Future of Jobs report. Every year they come up with this report. I will show you the latest thing, which also is giving you a prediction for the next 5 years. And in fact, in this document, for some of the analysis, they have used data science to be able to analyze this data. So everywhere they are using it. And the why is now the right time? Business leaders are consistently citing difficulties hiring data analysts and scientists, AI machine learning specialists, software application developers in the emerging roles. Most of the companies, 55% say skill gap is there. Okay, so that 40% in 2015 has moved on to 55% in 2020. It's not coming down, it's increasing because more and more companies are actually getting into that. Every company, every department, HR groups, and just now as the question has come up, tax. And I would have thought tax should have been something at the forefront of this thing, but unfortunately, actually, data science is coming a bit later to the tax. Of professionals are utilizing it more. And so whoever asked the question, actually, I should applaud that they are the leadership, because I had done corporate training for one of the leading companies, a big four kind of a company, and the tax group was really getting into that. Whereas in that same company, HR was already getting data science training for a couple of years by that time. So things like that. But there is a skill gap, and that means this is the right time. And while an exact skills match is not a prerequisite to making a job transition, that's also the thing. You don't have to have those exact same skills, but you have to pick up those skills pretty fast, which can be done with variety of courses that we are going to be talking about. So who is looking for that? Well, industries. And again, from that same thing, I won't go into the details, but the idea is that artificial intelligence is everywhere. If I look at that thing, 62% of the companies, 95% of the companies in digital information and communications, 89% in healthcare, all these are using artificial intelligence big time. Big data analytics, you may want to call it by different names, all are doing same kind of stuff. And the minimum there is actually 62% of the companies. Agriculture, and that's big. If I can get Google satellite images, etc., and I can identify where the crop yields can improve, soil conditions, etc., can be mapped, and then do that. And it's really a big thing, that agriculture. So I'm surprised it's only 62% in agriculture, but this is the data that has been collected from the surveys that were done. But this is going to increase. Everyone really needs that badly. So the primary question, can I build a career? Who can build a career? I do. What kind of background am I supposed to have? And again, I will go back to the same article. And what that says is, more opportunities are available currently in fields like data and AI, product development, cloud computing, etc. And that such transitions do not require a full skills match between the source and the destination. You see some kind of a crazy visualization, and our courses have data visualization. That's part of data science learning, and that's part of a full-fledged program. How do you visualize to tell a story to non-practitioners and help them take good decisions? And if you see, data and AI is somewhere here, and this is one of the very few areas where practically everyone is coming. You see, when I want to go into cloud computing, primarily people from engineering and information technology, those are the only big thing. These are the original, what am I currently doing, and this is where I want to be. And those are the only two people going there into cloud computing. Obviously that has a heavy computer science requirement, but data and AI, all of these are small, and there are many small things. You can come from engineering, marketing, information technology, education, variety of fields that are being there, research. And I will show some more about this in the next couple of slides. So this is where I'm talking about that. It is common for individuals moving into data and AI to lack key data science skills, but they should be able to master such skills like statistical programming within a recommended time frame. So opportunities in the next 5 years for data and AI jobs, massive opportunities for artificial intelligence specialists, data scientists, data engineer, etc. All these are available right there. And the skill gap, as you can see from the current roles, people in advertising, digital marketing, full skill gap. They have a huge gap from the data science field, but this is about successful job transitions. They have collected data in the past 5 years, 2015 to 2020, of people who have transitioned into data and AI related jobs. And many of them were from areas that were completely did not have the right skills. Many have data science, artificial intelligence, they don't have any gap. Natural language processing, they already knew those kinds of things. But many other people, computer networking, management consulting, variety of people have transitioned. We ourselves have seen people from biology, etc., do that all the time. But that's something that is important. But the important thing is getting to learn those things, and I will show you what you need to learn before I will pass on to Dr. Brinda for the course details themselves, and we will take a lot of questions also. What roles can you expect in data and AI? This is just a sampling, top 10 kind of a thing, but every company defines their role in a differently because it's all still evolving a lot. Artificial intelligence specialist, data scientist, data engineer, analytics consultant, variety of these things. Okay, and which is what I showed in the previous slide as well. But the top 20 job roles in increasing demand across for the next industry, across all industries in the next 5 years, and top 3 of those top 20 are all data analysts and scientists, AI and machine learning specialists, big data specialists. These are the kinds of things, and even other jobs require dealing with data. I don't think anybody can get away from data in these times, but specifically AI, machine learning related jobs, I mean, they are going to be leading the pack in the next few years. So, final thing, how can you kickstart? Well, some skills that you require, I will show 2-3 slides and then pass on to Dr. Brinda for the specifics of the program. But for you to understand at a higher level, hacking skills, math and statistics knowledge, and domain understanding. These are the things. But when we say hacking skills, in fact, Drew Conway, who made this and a pretty well-known data scientist in the world, he himself says, doesn't mean this needs enough programming skills, but it doesn't mean that you have to have a background in computer science. In fact, many of the most impressive hackers I have met never took a single CS course. I have seen a recent one, a BCom graduate, who actually, after our program, during the program itself, towards the end, won the national hackathon conducted by Analytics Vidya. And he was a BCom graduate with no background in programming, but you can pick up these skills. Picking up the necessary programming skills is important, for which you have to have hardworking attitude and dealing with some rigorous coursework. Math and statistics, again, you need not need a PhD in statistics. In fact, you don't need all the heavy statistics that is needed for data science. Only part of that is required here, and that's where you have to be able to deal with that thing. And some of these things are part of every course that is taught in data science. And obviously data science will not be complete if you cannot relate it back to your business, the problem you are solving, and thinking about that. It's not a pure technical thing, and that's why having programs that combine the technical and the business aspects, like this tech MSc program is doing, where both these skills are essentially very important to be able to take very good decisions. Otherwise, there is sometimes people just go in two different directions. The managers, the business people have no clue about the technical depth, and the technical people don't realize why they have to solve what they are really solving, and then the projects do fail. So that's something that will be needed. And all these three things, from the article that I have picked, the skills, they are pretty much the same thing. What are the courses you should be learning, which are part of what we always do anyway? Data analysis, computer programming, the necessary programming in R, Python, etc., that you need, general statistics, and some business programming, and all those kinds of things that you have to learn. And they have given some number of days that would take to learn each of them. And if you count, it's practically around what this MSc program is going to deal with. And so, why should you need a master's? Why can't I just learn something? Well, multiple reasons, and a lot of our alumni have been talking about it. First of all, it's exciting. So learning the subject is something very, very important. If you have the aptitude for the mathematical way of thinking, you don't have to do derivations, etc. That's in college, that's over. But to be able to build good models, solve problems, understand the outputs, etc., you need those things. And obviously, career options increase, more so when this analysis was done on this thing, on this job platform. Half of all data science job listings required a postgraduate qualification. So practically, it doubles your thing. You may learn without getting a master's thing, etc., but have a lot of companies have been asking for these advanced degrees, and having that additional rigorous curriculum to be able to learn very quickly these topics and be able to apply gives you that additional edge that not everyone may have. And with that, I stop my part of the talk, and I'll pass it on to Dr. Brinda, and we will of course take any questions that may come. But Dr. Brinda, yeah, I took about 40 minutes here, so
No problem.
please.
Thank you so much, sir. Thank you. Thank you for the wonderful insights that you've given us about this exciting field wherein we design several applications across different industries. Now, in order to be able to do that, let me just walk you through what what this program has to offer and how this has been designed. So quickly to tell you what is the duration of this program. This is basically a 2-year long program, which is 24 months. And the validity of this program is for 48 months, right? And this has been, or this is spread across 8 academic terms. The idea of splitting this across different terms is to be able to ensure that a student goes through various courses in math, computer science, programming, AI, ML, and management. Right? Now, the way the program has been designed is you will take one course at a time. Right? So you finish one course, okay, and then you move on to the next. Many a times, I will just show you what courses we've designed, but the way this has been done is you basically finish, let's say, the fundamentals or the foundations of one particular course, and then you will be drawn to learning some advanced topics. So to speak about it, as I said, the course or the program is spread over 8 terms, as you can see, from quarter 1 unto quarter 8. In quarter 1, we're focusing on courses based in maths and computer science, wherein we're teaching you foundations of probability and statistics. We're teaching you data structures and algorithms, and then taking you to a few topics such as advanced mathematical analysis. Now, over the terms, the way we have designed it, like I said, is you are graduating into more, concepts which are slightly difficult to assimilate once you have your foundations set. So in quarter 1 and 2, you basically go through courses in math, computer science. Okay. In quarter 3 and 4, you are introduced to courses in AI and ML. Okay. In quarter 5, and just like what Professor said right now, Dr. Sridhar mentioned to us that it's, if you know all the tools and techniques but do not understand the domain in which it has to be applied, it really will make no sense, right? And thus, keeping that in mind, we have introduced certain management courses as well, as you can see in quarter 5 and quarter 6, which basically will get you to apply whatever you have studied, the different techniques, by understanding the business domain and knowing what kind of decisions are you to make for taking your business ahead. What's also interesting here is if you look at quarter 4 and you look at quarter 5, we offer certain electives. And these electives have typically been designed keeping in mind what are the contemporary practices the industry needs at this point in time, right? So the 4 electives that we offer, and student needs to select any one of these across both the terms, right? So the first one that we've got is computer vision fundamentals and deep learning applications. The second elective that we're offering is text mining NLP, and back again, deep learning for NLP. The third one that we offer is big data. Okay, we've got big data, an overview of data and Hadoop ecosystems. As we all know that the different industries Sir spoke about right now will basically have humongous data coming in, right? So it's not only about having the massive data, but also being able to process it appropriately in order to derive insights. Big data will essentially come very handy there. Then again, the fourth elective that we've got is robotics and autonomous systems and reinforcement learning. These 4 electives are currently what the industry practices, and that's the reason why we have kind of introduced them, leaving you as a student with the ability to pick up something that comes very close to your liking, right? Then in order to basically check and let you as a participant know whether you've been able to assimilate and apply what you have studied in the real world context, right? In quarter 7, we've introduced something which is known as the product deployment boot camp. All right. And along with this, also towards the end of quarter 7, we've got something which is known as master's dissertation, which basically occupies a part of quarter 7 and all of quarter 8. I will just tell you in a moment what exactly do we do in both these areas, right? So if you don't mind, can you just go back to the previous slide? Now, whilst we are teaching you all these courses, there's one noteworthy thing that you would like to look at. We're covering several programming tools in order to be able to help you with these courses, right? So a student will study R, which again is a free source, open source software. You can practice it anytime. And you also have an entire, I would say, a set of programmers who can assist you should you need any kind of help, right? Similarly, we are also teaching you Python in the program. And as a data visualization tool, we're also teaching you Tableau. Right? So these are the primary 3 softwares which are open source and we will be using. Besides that, for students who will opt for certain electives, right, we also will be laying a focus on GitHub. There will be Docker. For students who will use or study big data, you will also be exposed to technologies related to big data. Shasta, if you could just move to the next slide. Now, speaking about the boot camp and speaking about the master's dissertation, right? Why are these so important from the student's point of view? So as you can see, these are strategically placed in quarter 7 and quarter 8. The idea here being that you are now going to apply whatever you've studied in the earlier courses. In a boot camp, this is basically an immersion program wherein a student will visit the campus for 7 days. And out here, he's going to be involved in designing 2 prototypes. right? So you will be given 2 independent projects that you're supposed to work on and finish in a span of 7 days. To give you an example, you may wonder what kind of projects would I actually be doing in the boot camp, right? So sir walked us through various examples of what exactly, what exactly do you see? Like you see a recommender system, right, on Amazon, which could recommend what could be the next product that you could buy, right? You could develop a chatbot here, which essentially will help you answer all the initial queries a customer has, right? So that they don't make calls and a lot of your productive time can be saved, right? So these two prototypes that you will essentially build will help you understand and apply whatever you have learned through the terms, right? Now, coming to the master's dissertation, the master dissertation is more immersive in nature, right? What do I mean when I say that? This will require a lot of time, a lot of reading, and a lot of application as well. But throughout this entire dissertation that you go through, you will constantly be guided by a faculty. Now, what exactly are you expected to do here? Right? In this dissertation, you will be given an objective or an area to study, a research problem from the industry, so to say, right? And you will be given cues as to what you could read up, okay, or how a similar industry would have tried to solve the problem. You are supposed to replicate this and find a solution to the problem that has been given to you, right? Doesn't that sound very exciting? So, which means there is some work done there is some problem in the industry, and based on whatever you've studied and mentoring, you're now supposed to propose a new solution, right? There's a lot of learning, believe me, if you actually devote time. We envisage students to come up with new solutions to problems in the industry, right? So this is immersive in the nature, and believe me, we've seen students wanting to read more, solve more problems. A few of our students have also gone on further to publish papers, right? Research papers in the area. So these are the two more exciting part of the program, which actually get you to apply what you've studied. All right, moving on to the next. We usually get questions around what is the eligibility, into this program? What should we really be, what should we have studied earlier in order to get into this program? Now, having said this, the eligibility for this program is any student who basically has, you know, uh, taken a formal degree, maybe in BTech or B in computer science, or somebody has studied BTech or B and has a statistical background, or somebody who has a bachelor's degree in math, economics, okay, or so to say, science, with some kind of a mathematical component in it, with 50% of marks that you have scored there, and have a 2-year work experience, I believe you will be able to really cope well with our program. Similarly, for those students who have undergone a formal degree in MTech or ME in computer science, statistics, or have a master's degree in math, science, or any kind of a math component in it, and have scored 50% marks and have 1 year of work experience, back again, we think you will be able to enroll in this program. The idea is for those students who've gone through any of these formal degrees, we make an assumption that you've also studied programming. While programming is preferred, okay, for candidates, we also teach you programming from basics. But students who probably have not studied it, I would recommend you to kind of pull up your socks, practice a little bit more, and you definitely can make it through the program, right? So can you just take me one slide behind? In order to be able to facilitate you throughout this entire program, we've got course coordinators who are your point of contact whenever you want to know more about the program, or in cases you've got doubts and you want to escalate it to a faculty. We also have a facility with the help of which you can reach out to faculty directly in order to get your doubts clarified. And this is basically with the help of Post My Query section that we've got on the student portal on our LMS. What we've also tried to do is we've tried to engage with students by creating or having these sessions, okay, on Fridays typically. So we've got our learning classes from Monday to Thursday. Okay, these are in the evening from 7:30 p.m. to 9:30 p.m. What we've also done is for certain courses, we believe it would be great to interact with industry experts and learn as well what's happening in the industry at that point in time, right? So we facilitate these discussions on a Friday for certain courses, wherein we get you to know what's happening in the industry. We get you to interact with your classmates as well, right? And should you have any further more queries, if you want to kind of reach out to a faculty and yet know a little bit more on what you're working on or how you want to apply an algorithm, we can also schedule a call with a faculty with a book slot, right? So there is immense support that we would like to provide to you, as long as you would like to also invest the kind of time in a program. For those of you who really want to get into this field, believe me, this is a comprehensive program which we've tried to put together by designing several courses and making it very relevant to what the industry needs at this point in time. I would recommend it to most students who want to get into this field. Please go ahead, go through what we have to offer. If you've got questions, please ask us questions around it, and we'll be more than glad to help you. Sure. All right, let me just take a few questions here. So there's this first one, uh, which says, do we have a weekend batch? So Shruti, to answer that question, at this point in time, we do not have a weekend batch. This is going to be a weekday batch from Mondays to Thursdays in the evening. We reserve the weekends only for examinations, and we, considering this is for working professionals, we would like to give them the weekend to themselves. Back again, another question by Arjun Sharma. What's the validity for 48 month exactly mean? This means whilst the program is for 24 months, you can complete it in 48, which goes on to say that if you need to take a break in between, let's say you have to go on site for a project and you would like to exit for a point and then re-come back to the program, you need to finish it within 48 months from the day that you have registered. That's why we say a validity of 48 months. Uh, okay, so Kritika, it's another question. She says 15 minutes call is a one-on-one call, which basically is to help you resolve your problem, right? Okay. Okay, back again, coming to the eligibility, which is a question here, right? Anonymous attendee, as you say, the eligibility for the program is something that we've just mentioned on the slide. We would encourage students who've got a mathematical background and a programming background to apply. However, if you don't have a programming background, this is a rigorous program. I would, whilst we will help you with the basics, I would usually recommend students to invest a little bit more time in honing their skills, and they can definitely make it through the program, right? So that's what it is. Okay. One question that you could help us with, sir. Is AI needed for data science? We have one student who's asked us that question. So if you could please help us with that.
Yeah. So like I said, sometimes I am actually stumped by such things, because to me, a lot of this is interchangeable. Data science, AI, ML is one thing. So the way I see it is that data science is that bigger circle, and AI and ML are two parts of it with some overlapping in there. So data science is a general thing where you are using it. So you could be doing solving a variety of problems. It all now depends on problems. If I'm using only linear regression, logistic regression, or naive Bayes, etc., some statistical modeling, I don't need to get into probably AI algorithms, and I'm still doing data science. But am I doing data science when I'm working on some AI things uh, the autonomous car kind of a thing, or computer vision related stuff? Well, that is also data science. So yes, and that's why this whole program is very comprehensive. Statistics is the foundation. So we start with the statistics, we then go into the machine learning algorithms, then into AI and kind of some futuristic kind of techniques that are solving those kinds of problems. So all of that gets covered in this thing. So briefly to answer the question, is AI necessary for data science? Well, no, because you can solve variety of problems without the AI part of it. But is AI part of that whole data science thing? Yes, it is part, and it is part of the curriculum as well. If I have not answered it, then
No, no, no.
please ask a follow-up question. Otherwise, that's the thing. So I don't want you to really get hung up on the definitions. Also, they are, people use them interchangeably. Many times people don't know why they are using it. So when you see AI, ML, data science, etc., in newspapers, just assume they are all talking about the same thing. That's it.
Sure. All right, sir. Thank you so much. Those were the set of questions that we've got. For a few participants whose questions probably went unanswered or so, in the chat window, we basically have provided you with the details of contacting us. So if you could just take us to the last slide. Back again, we've got details on the email ID that you could reach out to us on, right? So we've got our website available here. We've also got the email ID. You could just drop your questions and we'll be more than glad to help you, right? Thank you so much, everybody. And thank you so much, sir, for this wonderful session that you've helped us with, understanding so much more about this field. Yeah.
Thank you everyone for attending and sticking around for this 1 hour, 15 minutes. And thank you for giving me an opportunity to speak, Dr. Prinda. Thank you.
Sure. Thank you. Thank you so much, sir.